What is sampling rate in analog to digital conversion? Imagine trying to capture a moving object with a camera. The faster it moves, the more pictures you need to see its motion clearly. The same idea applies when converting an analog signal into digital form. The sampling rate is how often you take a snapshot of the signal each second. It is measured in samples per second or hertz. In electronics and embedded systems, this rate is very important because it affects how accurately the digital version reflects the original analog signal. If you take too few samples, you might miss important details. If you take too many, it can require more processing power and energy. The key principle here is the Nyquist sampling theorem. It states that to perfectly recreate the original signal, you need to sample at least twice the highest frequency present in the signal. For example, if your audio has sounds up to 20,000 Hz, you should sample at least 44,100 Hz to avoid losing information. Sampling below this rate causes a problem called aliasing. This is when high-frequency signals are misrepresented as lower frequencies, leading to distortion. Imagine a wheel spinning so fast it appears to be still or spinning backwards in a video. That is similar to what happens with aliasing in signals. Sampling at a higher rate than the minimum helps improve quality. For audio, common sampling rates are 44,100 Hz or 48,000 Hz. These ensure the sound is clear and free from distortions. In digital electronics, the sampling rate also influences the bandwidth of the analog to digital converter. Higher rates mean the hardware needs to be faster and consume more power. But they also give a more faithful digital representation of the original signal. In summary, the sampling rate is how often you measure an analog signal each second to turn it into digital data. Picking the right rate is essential to capturing all the important details without distortion. Following the Nyquist criterion helps ensure the digital signal is a true reflection of the original. This concept is fundamental in electronics and embedded systems for accurate signal processing.